Why, hello, my geometers. Welcome back to some geometry problems. I hope you can hear me. I'm using a new mic today, so hopefully everything will be fine. I'll proof this later and then record it again if it doesn't work. But today we're going to be talking about parallel lines that are cut by a transversal. Okay, so parallel lines are obviously these ones here that have the same slope. Okay, and in geometry we mark these lines as being parallel by putting arrows on them. So when two lines have arrows on them, it means that they are parallel. And this is going to be your transversal, the line that cuts across them. And as you notice, when two lines are cut by a transversal, you get 8 angles created. Okay, these 4 angles up here and these 4 angles down there. Okay, now here we have a set of vertical angles still. Here's another set of vertical angles. Sorry, that's the bell. We still have linear pairs, so 1 and 2 form a linear pair, 2 and 3 form a linear pair. They're supplementary. So all this stuff still applies that we've had before, only now we have 2 different groups of them. So when parallel lines are cut by a transversal, we get 5 different types of angles. Okay, and those are what we're going to be discussing today, are the 5 types of angles that you get when parallel lines are cut by a transversal. Okay, the first set we're going to talk about are corresponding angles. Corresponding angles are those in a similar or common position on your page. Okay, I hate to use the word correspond, but it's angles as they correspond. They are in a similar position. If you think about it as streets, they're on a common street corner. So let's just best by describing some. So a pair of corresponding angles would be like angle 2 and angle 6. 2 and 6 are corresponding angles. So here is angle 2, it forms this angle, and here is angle 6, it forms this angle. So notice both of these angles are formed using that same transversal, but different parallel lines. So notice they're on the same kind of positioning as far as each other go. They're both on the top, if you will, of their parallel lines, and they're on the same side as your transversal. So they're in a corresponding position. So 2 and 6 are corresponding angles. Similarly, angle 3 and angle 7 would be corresponding angles. Likewise, angle 1 and angle 5 are corresponding angles. And angle 4 and angle 8 are also corresponding angles. Okay, they are in a corresponding position. Now, there is a postulate that says if parallel lines are cut by a transversal, corresponding angles are congruent. So not only do they have a name, they also have a relationship. So this is how they relate. They are equal in measure. If one is 72 degrees, the other one is 72 degrees. Okay, it's important to know how corresponding angles relate. This is how they relate, their relationship. 4 is the same as 8, 1 is congruent to 5, angle 3 is equal to angle 7, and so on and so forth. Okay, corresponding angles are congruent. The corresponding angle postulate says that. Okay, another type of angles are alternate interior angles. Okay, you find alternate interior angles between the parallel lines and interior and on opposite sides of your transversal. OPPOSITE. Opposite sides of your transversal, hence the alternate. Okay, there are only 2 pairs of alternate interior angles within a set here. So one example is angle 4. It is between the parallel lines, and angle 6. Okay, on opposite sides of your transversal. So angle 4 is here, angle 6 is here. So angle 4 and angle 6 are a pair of alternate interior angles. Okay, likewise, we have another pair. Angle 3 is also inside or between your parallel lines. And angle 5 is also, but it's on the opposite side of your transversal. So angle 3 and angle 5 are also a set of alternate interior angles on opposite sides of the transversal and between your parallel line. Okay, the alternate interior angle theorem, which I will prove later. The alternate interior angle theorem, there's an E and an M on the end of this, but my thing is too far over. Theorem The alternate interior angle theorem says if parallel lines are cut by a transversal, then alternate interior angles are also congruent. Okay, and you will prove that later, but for right now, that is what it says. So their measures are once again equal. So if 4 happened to have been 114 degrees, then 6 would also be 114 degrees. Okay? If angle 3 were 66 degrees, then angle 5 is also 66 degrees. Okay, alternate interior angles are congruent. And of course, these two still add up to be 180. These still form a linear pair. Okay, so alternate interior angles is another set. Our third set, alternate exterior angles. So just like the interior ones, they are outside of your parallel lines, and that's the symbol for parallel, but still on opposite sides of your transversal. Okay, alternate as in opposite sides of the transversal and outside of your parallel lines. So here is an angle that is outside of the parallel, angle 1, and we have to go outside and alternate. So if this is on the left side here of our transversal, the one that connects with it is number 7, also on the opposite side of your transversal. This one's on the right side and outside. So angle 1 and angle 7 are a pair of alternate exterior angles. The other pair would be angle 2, which is on the outside of your parallel lines, and angle 8, which is opposite of the transversal. So here is a pair of alternate exterior angles. And there's also a theorem associated with this one. If parallel lines are cut by a transversal, then alternate interior or exterior angles are also congruent. Okay, so once again as an example, if angle 1 were 60 degrees, that means angle 7 would also be 60 degrees. And thus, angle 2 would be 120 degrees, and so would angle 8 be 120 degrees. So whatever these ones are, their opposite outside is also the same. Our fourth set, consecutive interior angles. Okay, consecutive as the next one over. Interior is between, so still between your parallel lines, but consecutive means on the same side of the transversal. In fact, these have been sometimes called same side interior angles. So let's identify a pair of consecutive interior ones. So here is an angle. Angle 4 is on the interior of these parallel lines. Okay. Angle 5 is also interior and on the same side of the transversal. So angle 4 and angle 5 would be an example of a pair of consecutive interior angles. Okay, they're both on the left side of this transversal and they're in between your parallel lines. And the other set would be angle 3, also interior, and angle 6 on the same side of the transversal as angle 3. So that's a horrible copy. So angle 3 and angle 6 are also consecutive interior angles. Okay, and the theorem, consecutive interior angle theorem, says that if parallel lines are cut by a transversal, then consecutive interior angles are supplementary. Okay, they add up to 180. That's what it means to be supplementary. Add to 180. So if angle 3 happened to have been 70 degrees, that means angle 6 would have to be 110 degrees, because 70 plus 110 is 180. Okay, likewise over here, 4 would have to be 110 degrees, and this would have to be 70, because these still have to add up to 180. These still have to add up to 180. So here we also have alternate interior angles. As you can see, they are congruent. So consecutive interior angles are on the same side of your transversal and in between the parallel lines, and they are supplementary. They add up to 180. And our last set, consecutive exterior angles. So like you might think, they are on the outside of your parallel lines and on the same side of your transversal. Okay, that is where we find them, transversal. So here, let's start with angle 1. Angle 1 is on the outside, so here's angle 1. And to find its consecutive exterior, we stay on the left side of this transversal, and so we get outside of your parallel lines. So here it is, angle 8 is consecutively exterior with angle 1. So angle 1 and angle 8 are consecutive exterior angles. And as you might think, on the other side is where we're going to find our other pair. Angle 2 is consecutively exterior to angle 7. So angle 2 and 7 make up that other consecutive exterior angle pair. Okay, those are your consecutive exterior angles. So on the same side of the transversal and outside of your parallel lines. And the theorem says that if parallel lines are cut by a transversal, then consecutive exterior angles are also supplementary, just like their consecutive interior angle friends are. Okay, so if angle 2 were to have been 125 degrees, that means angle 7 would have to be 55 degrees, because those two angles add up to 180. Okay, likewise over here, this one would have to be 55 degrees, because these two add up to 180, and this one is going to be 125. These two add up to 180. In fact, when we do the proofs, we will use substitution and the definition of a linear pair in order to do the proof of this theorem. This says consecutive exterior angles are supplementary. Okay, so those are your 4 different types of angles. Now let's take a couple minutes and do some algebra with them. So we're given that we have parallel lines. Line A is parallel to line B. Start with that. So that means that all of these relationships apply, congruence and supplementary, depending on which one we're talking about. Okay, all of them apply. If angle 2 is 2x plus 4 degrees, and angle 6 is 6x minus 20 degrees, what is the measure of angle 3? So first of all, we have to identify angle 2 and angle 6. Angle 2 and angle 6 are corresponding angles. Okay, notice they're in a corresponding position. This is in the top right corner of its group. This is in the top corner of its group. Corresponding angles. And the theorem of the postulate says that corresponding angles are congruent, which means the measure of angle 2 equals the measure of angle 6. Okay, that's how they relate. They have an equal relationship. So now that we've identified them and we know their relationship, we can substitute our two values, 2x plus 4 and 6x minus 20, to make an algebraic equation that we are then able to solve. So I'm going to add 20 to both sides, I'm going to subtract 2 from both sides, and then I finally end up with x equals 6. Okay? And that is fantastic that x equals 6, although the question is, what is the measure of angle 3? So in order to calculate the measure of angle 3, I'm going to go ahead and figure out what the measure of these angles are. So if I plug this back in, 6 times 2 is 12. 12 plus 4 is 16 degrees. So this angle is 16 degrees. I know it doesn't look like it. This does not look like a 16-degree angle, but the math that we just did says that it's a 16-degree angle. So it looks like I have drawn this picture horribly wrong. But that's okay. 16 degrees plus the measure of angle 3. So angle 3 plus 16 degrees has to equal 180, because these are a linear pair. They add up to 180. So that means that the measure of angle 3 is going to be 164 degrees, even though it does not look like it. According to the math, this is true. Okay? So believe your math, don't always believe your eyes when it comes to geometry problems. Okay, we have corresponding angles. They are congruent, so you set them equal and you solve for x. We plug it back in and we find something else. Okay, it's a wonderful geometry problem. So our last one, given we have parallel lines once again. Okay, that's awesome to know because then all of our theorems and postulates are true. Measure of angle 8 is 5x plus 16. Where's 8? Here it is. 5x plus 16 out here. And measure of angle 1 is 3x plus 6. And once again, what is the measure of angle 3? So the first thing we have to do is identify angle 1 and angle 8 are what kind of angles. So here this is on the outside of the parallel. 8 is also on the outside of the parallel, and they're on the same side of your transversal, so these ones must be consecutive exterior angles. So angle 1 and angle 8 are consecutive exterior angles. So how do they relate? Well, the measure of angle 1 plus the measure of angle 8 is 180. That's what the theorem says about consecutive exterior angles, that they are supplementary. Okay, so we write down their relationship, and now we can do our substitution so we can create an algebraic equation. 3x plus 6 plus 5x plus 16 has to add together to give you 180. Okay, so we name them, we figure out their relationship, and then we substitute so that we can make some algebra and solve this for x. So solving for x, 8x plus 22 equals 180. So 8x equals 158, I believe. Let's check that real quick. 180 minus 22. Sure enough, 158. So dividing this by 8, let's come back over here, 158 divided by 8 is 19.75. Okay, so don't get disgruntled that we got a decimal, that is okay. It's just a decimal math problem. So 19.75 is your answer for x. So is that what we want? No, we want to know what is the measure of angle 3. So to which angle does 3 relate easiest? Does angle 3 relate to angle 1 or does angle 3 relate to angle 8? Okay, and I would say the easiest relationship here is between angle 3 and angle 1. So angle 3 and angle 1 are what we call vertical angles, and we should know that vertical angles are congruent. So angle 3 is congruent to angle 1. So if I figure out what 3 times 19.75 is, and I can do that because I have a calculator, and add 6 to it, I can figure out what the measure of angle 1 is. So let's see, bring our calculator back, come over here, calculator, times 3 plus 6, sorry, and we get 65.25 degrees for the measure of angle 1. So, alright, measure of angle 3, that's what we wanted. Here, let me circle this one. There we go, because the measure of angle 3 and the measure of angle 1 are the same, because they're vertical angles. So this is what I wanted to circle. There we go. Okay, so we first identify the angles. What type of angles are they? We figure out what their relationship is. Are they equal or do they add up to 180? And then we solve some algebra, or we create and solve some algebra so that we get x, and then plug it back in to figure out what our answers are. Okay, I hope this has been helpful in dealing with parallel lines cut by a transversal. We'll see you on the next film.